So welcome back guys, welcome to eCareerPoint-English medium channel. So how are you everyone? Hello, good evening Sudeshna, Vinayak, Jayant, how are you? So is everyone alright? And I am hoping you guys are in good health, in amazing health. Hello. So I have finally decided upon the topic. Yes, for the next part of this. So many of us were wanting organic chemistry. So we will proceed with organic in the next part. So don't worry about it. It will begin, or we will begin with the first chapter of 11th. Yes. So we will start with organic in full spirit. So don't worry about it. Don't worry, Vinayak. Okay, so amazing. All the best for your result, Vinayak. I am hoping that you will surely qualify it. Yes, amazing. So Jayant is good. Nega, how are you? Okay, so many of us were wanting organic chemistry, so we will finally begin with organic. Yes, I am hoping this will be the last lecture for this mole concept, and then we will begin with organic. Okay. Okay. Nega, I am always there for you. Don't worry. If nothing happens, in any case, we are waiting for anyone to come. If nobody comes, I will myself take your 12th lectures. So don't worry about it. I will take eventually if no solution comes. Okay. So once you wanted organic to begin, so I am taking organic for you. Eventually we will also take other lectures as well. So don't worry about it. Okay. So first of all, let's begin. So for that, you already know the drill. What we need you guys, so that this topic, the topic of one of the most important topics in mole concept, that is eudiometry. So this eudiometry, it's a very easy, very simple topic, but it becomes difficult because we are not thorough with our basics. So we will focus on our basics. Yes. Okay, so there is Anushri. So in this previous lecture, you took a question, calculate volume percent of 10 volumes. Can you please repeat this question? Can see my question? Anushri, I saw your question, but I don't have that slide right now. So I will do one thing. I will bring that question in the next slide. Okay, and then we will solve that question again for you. Sure? Okay. Okay, Nega, I am on it. But even for +2 organic, you first of all need your +1 concepts to be cleared. Yes. So we will focus on your +1 organic, because why are you facing problem in organic? The only reason you are facing problem in organic is because your +1 organic is weak. Because GOC, it is the main foundation. So first of all, you have to focus on general organic chemistry. I will take that lectures, and eventually we will proceed to +2 organic as well. What is +2 organic? It is just the reagents. But how the reagents will work? We will learn this in 11th class. Okay. How many lecture? Jan, this is the last lecture for organic, for this mole concept. Then we will begin the organic part. Okay. So is it clear, Nega? Yes. Okay, Vinayak, don't worry. This is even required for JEE as well. This is a topic that comes in JEE also. So you have to work on this. Okay. Sure. So let's begin. That is, again, in case you are willing to get the paid course, you can use this code, that is NS10. This will help you to get 10% off on all the paid courses, and hence you can, get the courses at a lower price. Okay. Yes, and in case you are still willing to join this course, that is 100 days for complete physics in 100 days, you can get this. So this is for NEET aspirants just like you. You can get, if you want to complete your physics in 100 days, including DPPs and live solutions and doubt discussions, you can get this course. Again, use the code NS10 to get 10% off. Okay. Okay, so let's proceed towards empirical formula. Okay. Okay, okay, Jayant is saying next topic kaun sa hai? Okay, Jayant, we are working on first of all organic. So I will give a schedule. I will plan a schedule for the organic part. So don't worry, it will be done eventually. Yes. So let's begin. So for the empirical formula, let's take an example. Because what happens is, in this mole concept, in any case, even if it's organic or inorganic or anything, you will come across this concept of empirical formula. So what exactly is there in this empirical formula? For this, let's take an example of very simple formula structure that is called this. So what is this? You guys might be familiar with this structure. Yes, this is called what? Acetic acid. Okay. So this is the structure of what? This is the structure of acetic acid, whereby I can see there are two carbons and the bonding of carbons as well as, because this carbon is bonded to 3 hydrogens, then it is bonded to another carbon, and this carbon is further bonded to different bonds. So what I can see right now is, I can see the bonding in the structure. So when I can see the bonding, then what we will do? Then this structure, it is known as structural formula. So when I am thorough with my formula, that is, I know the structure, it is known as structure formula. But what if I only write the number? That is, there are 2 carbons, so I simply say this structure has 2 carbons. There are how many hydrogens? 1, 2, 3, 4. So there are 4 hydrogens and there are 2 oxygens. So what if I simply write the total number of atoms and atoms present in this compound? So when I write just the number, the total number of atoms, then this compound, this structure, whichever this formula is, this formula will be referred to as molecular formula. So what is this? This is molecular formula. When I only know what? I only know my number. I don't know the bonding. If I am not familiar with the bonding, then it is called molecular formula. If I am familiar with the bonding, then it is called structure formula. Okay? Okay, Jayant, I will surely take your query. Don't worry. Then Vinayak, this is not ethanol. Ethanol is something else. This is acetic acid. Yes? Okay? Okay, so Ansab, even I am doing this for you. Don't worry. We will begin with organic. And I am sure we will complete the organic. Yes, we will take 1 hour sessions. Okay. So don't worry, it will be done for you only. Especially I am doing this organic part, because this is the main interest right now, that we have to get ourselves, completely accustomed to organics. So it will be done. Organic will become your strong point for every one of you. So don't worry about it. Okay. But what if, regarding this, what if I simply say, I have right now what we have? We have 2 carbons, 4 hydrogens and 2 oxygens. So I can also write a simple formula. Yes, right now what is the ratio? Ratio of carbon to hydrogen to oxygen. So ratio is coming out as 2:4:2. What if I find the simplest whole number ratio? I can also find that what if I divide the whole number by 2? That is 1:2:1. So when I am dividing the whole number, I am finding, let's say LCM and dividing it by the LCM, I am finding the simplest whole number ratio. Now what is this? C1, H2 and O1. Now what this is? This is simplest whole number ratio. So simplest whole number ratio. Now when I find the simplest whole number ratio in this case, now this specific formula, it doesn't tell me the actual number of carbon, because in our structure, in our compound, we had 2 carbons. But what this formula is telling me? It is just telling me that there is 1 carbon, but it is not that. This formula simply tells me what is the ratio of carbon to hydrogen to oxygen. That is, for every carbon atom, there will be 2 hydrogen atoms and there will be 1 oxygen atom. Now this formula, this is known as empirical formula. Okay. So what is this? When I only have the simplest whole number ratio, then that structure will be known as empirical formula. Now is this thing clear? Okay. Yes, organic chemistry. Yes, Jant, I am already working on it. So don't worry, it will be started from the basics, from the ABC, and then we will talk about the highest levels. Okay, so 1:2:1, exactly. Okay, Vishu, we had a change of plan. We are starting with organic first of all, and if time permits, then side by side we can study with this as well. That is GOC. Sorry, gaseous. Okay. Okay, Ansab, means a lot. So it will be, a great help if I am helping you guys anyway. Yes, sure. So what is empirical formula? Empirical formula is simply the simplest whole number ratio. So when you take a compound, you can either know the structure, it is called structure formula. If you just know the exact numbers of atoms, it is called molecular formula. And in case you are knowing the ratio, it is called empirical formula. So what is empirical formula? It provides the simplest whole number ratio of different atoms in the molecule. So when it provides the simplest whole number ratio, it is known as empirical formula. Now there is one very important thing regarding empirical formula. Yes? Yes, exactly, Jan. This is also used in organic chemistry, your empirical formula. Now we have to understand the basics behind this. That is, in case of empirical formula, what if right now I have a formula, that is, what is the empirical formula? CH2O. So CH2O is the empirical formula of, let's say, this compound, which is our acetic acid. But CH2O can also be the empirical formula of, let's say, this compound, C2H4O2, or it can be, let's say, C3H6O3, or it can be, let's say, C6H12O6. So one empirical formula, it can have multiple molecular formulas. Yes, so one empirical formula is denoting what? There are millions and millions of molecular formula which can be shown by this empirical formula. So when I am saying I have a fixed empirical formula, for example, right now I am fixing my empirical formula, that is CH2O. So once my empirical formula is fixed, it does not mean that your molecular formula is fixed, because for one empirical formula there can be millions of molecular formulas. Is this thing clear? Thank you, Vinayak. Yes, so this is the drawback of empirical formula, that is, we simply know the ratio. We don't know what is the exact molecular formula. So this point is clear, that is, different molecules can have same molecular formula. So different molecules can have the same molecular formula. Exactly, Vinayak. So this is something which we need to know about empirical formula. But what about the molecular formula? Even the molecular formula, there is also slight problem. But what is exactly is the molecular formula? Molecular formula provides us the exact number of atoms present in a compound. Yes. So to define molecular formula, it represents the exact number of atoms of different elements in a molecule. So is this thing clear? So for example, let's say I have a compound, that is ethanol. So this is ethanol. Yes. Now this is, I am drawing what? Ethanol. So this is the structure of ethanol. So if I have to write the molecular formula of ethanol, then what it can be? There are 2 carbons. Yes. So C2. There are 1, 2, 3, 4, 5, 6 hydrogens, and there is 1 oxygen. So the molecular, this is the structure formula. Yes. So this is my structural formula, whereas this is my molecular formula. So I have molecular formula and it is denoting what? This is the structure formula. But again, just like in the relationship between empirical and molecular, again there is a problem with molecular and structural, because for one molecular formula there can be multiple options for structure formula as well. Just like, look at this. So there is a compound by this. Now what is this? This is called dimethyl ether. So this is my ether, that is dimethyl ether. Now, if I look at the molecular formula for dimethyl ether, there is 2 carbons. Yes. There are 6 hydrogens. Yes. There is 1 oxygen. Yes. So, again, one molecular formula can represent multiple structural formulas. So, again, we are not exactly sure about the structure. Structure can again vary, but molecular formula is the same. So, this molecular formula can represent this structural formula as well as this structural formula. Now, is this thing clear at this moment? Yes, exactly. Some empirical formula regards for. Jant, I am not, I didn't get your question. Please, can you reframe this question? Okay. So, this is again, so this is a problem that is in the molecular formula. Different molecules can have the same molecular formula, just like we took the example. So, in this concept of empirical formula, what we face is, what is the problem in this, the situation is, whenever you get a question on empirical formula, first of all, the question can be like this. I will show you the question. At this moment, there is a thing called mass percentage. For calculations, for the questions, with the question which you will face in exam, it would have a term known as mass percentage. So, first of all, let's understand what is mass percentage. Once we are thorough with mass percentage, we can solve the question based on this. Yes. So, there is a thing called, again, so there is a thing called mass percentage. For example, what is mass percentage of compound of any element? So, mass percentage of element simply means, for example, let's say I have water. Yes. Now, in water, I know the molar mass of water is 18 grams per mole. Yes. And the mass of oxygen in 18 grams of water, I have 16 grams oxygen and I have 2 grams hydrogen. Now, what if I ask you the percentage, mass percentage? When I ask you what is my mass percentage of oxygen in water, so you simply say it is the mass of oxygen, that is 16 grams, upon total mass of the compound, that is 18 grams times 100. Now, when we are talking about mass percentage of an element in a compound, it simply means the mass of that element, total mass of that element upon total mass of compound times 100. So, what is the mass percentage of element in a compound? What is this? What does this mean? It means the mass of total mass, let's say total mass of element divided by total mass of compound times 100. So, this is my mass percentage. Now, this is a value which will be given to you guys in the question. So, whenever we are given the mass percentage, you have to get yourself familiar with what it means. It simply means behind every 100 grams of solvent, how many grams of your element is present. Yes, behind every 100 grams of the compound, how many grams of your element is present? It means mass percentage. Yes, exactly. So, total mass of atom divided by total mass of compound times 100. Exactly, Anushri, you are perfectly right. So, this is how you can solve. For example, let's take a question on this. Calculate this. So, this is a question for you guys. Calculate the mass percentage of oxygen in H2SO4. So, try it and find the answer. What do you think? Try this again. You know the formula. What is the formula of mass percentage? I will write the formula for you. That is, mass percentage stands for, it is total mass of element divided by total mass of compound times 100. So, what is the total mass of element? Yes, hello Rishi, how are you? You have been late to the class. Okay, so yes, Vinayak, you have to learn the masses of some elements at least of first 20. So learn the atomic masses of first 20 elements of periodic table. Generally they are given in the question, but you guys have to learn at least of first 20. Okay. Jan, what is an empirical formula? Empirical formula is just a relation. There can be a different molecules based on one empirical formula. Just I took the example. There can be acetic acid was there was glucose. So glucose and acetic acid, they have the same empirical formula, but their properties are completely different. So exactly, you are right, the properties can be different, they may be same, but they are mostly different because they are representing different compounds. So Anushri has given me the answer, even Ansab has given me the answer. So let's see if this answer is right. So what is the total mass of element? We have to calculate of oxygen. So mass of oxygen is 16 and we have 4 oxygens. So 16 times 4 upon mass of sulfuric acid. Now calculate the mass of sulfuric acid. It is 2 plus 32 plus 64. So this value is coming out as 98 times 100%. And I think you guys are right. The answer would be close to 65%. So what does this mean? It simply means behind every 100 grams of sulfuric acid, there is 65 grams of oxygen. So this is what is meant by mass percentage of element. Okay. So is this thing clear? Vinayak, again, this is just an assumption. You guys have to learn the values, exact values, because those will make the difference. Okay. So this is clear. Now what exactly will we face in a question? So what is the type of question which will come in this? Now this is very important, and we guys will follow a simple set of rules. If you are following this set of rules, the question will never go wrong. Otherwise, there is a high probability of getting a wrong answer. Now this is a question which we can see. So this is how the question will come in your exam. That is, a compound contains this much percent of hydrogen, this much percentage of carbon, and this much percentage of chlorine. Find out the empirical formula and the molecular formula of the compound, and you are given with the molar mass. Now this is a question which we will see in our exams. Now how to solve this question? I will solve this question. This is a question which I will solve. Next question obviously you guys have to solve. At this moment, understand, I will follow certain set of instructions, certain set of rules, and using that many very rules, you will also solve. Okay. So what is the first rule? So first rule is identify what you have been given. So you have been given there is a compound and it has these percentages of compound. Yes. So what we will do, we will simply do one thing, that is we will assume, let's say we have a compound. So whatever formula we have to find, let's say the compound, what is the total mass of compound which we have? We will simply assume we have 100 grams of compound. So what I have 100 grams of the compound. Now if I have 100 grams of compound, how many grams of hydrogen do I have? So what is mass of hydrogen? So mass of hydrogen, it is 4.07 grams. Similarly, what is mass of carbon? So mass of carbon, it would be 24.27 grams. And what is the mass of chlorine? So mass of chlorine is simply how much? 71.66 grams. So this is my first step, that is I will assume 100 gram of compound, and according to that compound I will calculate the individual masses of the elements. Now is this step clear? Vinayak, don't worry, it will go away in some time, but for that you have to practice a lot of questions, and first of all you have to develop a mindset and a technique how exactly you will fire that question. Anushri, there can be same molar mass for more than one compounds. Different compounds can have same molar mass. For example, sulfuric acid and phosphoric acid, both of them has molar mass as 98. Yes. So what is my first step? First step is I have to assume 100 grams of the compound and I will calculate the masses. Yes. Now what I will do? Now here is my step. That is, once you have your masses, what you do? You try to find the number of moles. So what I will do in my step 1 is I will find the number of moles of each substance. Now how to find the number of moles? So number of moles of, let's say, hydrogen. It is given mass of hydrogen divided by molar mass. Yes. So what is the given mass? Given mass is 4.07 and what is molar mass of hydrogen is 1. So what I have, number of moles is 4.07. Similarly, what I will do? I will start calculate number of moles of carbon, which will be given mass divided by molar mass. Now this value will come close to, I guess, 2.03. And similarly, if I find the molar mass of number of moles of chlorine, it will be coming out as this divided by 35.5. Again, this value is close to 2.03 moles. Now what I did in the first step is I simply found the number of moles of each compound. Okay. Tanu, next chapter will start on from the next lecture. So we will start with organics. So don't worry about it. Yes. Now this is how we will calculate initially. That is, what is my first step? Simply convert your masses to moles. So I converted the masses of substances to moles. I basically calculated all the moles of the substances which are given to me for 100 grams of the compound. Now is this step clear at this moment? Yes. So this step is clear. Now what is my next step? Next step simply is find the ratio. So whatever you found the number of moles individually. In the next step, we will simply calculate what? We will simply calculate number in the ratio, that is molar ratio. So I have to find the ratio of hydrogen to number of moles of carbon to number of moles of what? Chlorine. So they are coming out as 4.07 is to 2.03 is to 2.03. Now this is my step number 2, that is we have to calculate what? We have to calculate the number of moles, that is ratio we have to calculate. Yes. Okay. Please consider daily. Answer, I am trying, again I am telling you there is a very tight schedule to be followed. Yes, whenever I get classes, I come on the channel as soon as possible. Actually there are many channels, so sometimes it becomes difficult. Yes. Now this is what I have to find in the molar ratio. This is my step 2, that is find the ratio of the moles. Yes. Now what I will do in step 3 is I will find the simplest whole number ratio. That is, in the step number 3, I will find what? In step number 3, I will simplify to the nearest integer ratio to get the empirical formula. That is what I will do. What was the ratio? It was ratio of hydrogen to chlorine, carbon to chlorine. It was coming out as 4.07 is to 2.03 is to 2.03. Now do one thing. If I have to find the simplest whole number ratio, which is the minimum number, which is the smallest number out of these three, that is 2.03, it is coming 2 times. So divide the whole numbers, all the numbers by 2.03. So I am dividing this by 2.03, I am dividing this by 2.03, I am dividing this by 2.03. So what is the ratio I am getting? It is coming out as 2 is to 1 is to 1. So that is the hydrogen to carbon to chlorine. It simply means for every 2 hydrogens, there are 1 carbon and there is 1 chlorine. So what is my empirical formula? It simply is hydrogen we are having 2, carbon we are having 1 and chlorine we are having 1. Now this is what? This is my empirical formula. Yes. Is this thing clear? This is the empirical formula which we have to find. Now this was the step 1 of our question, that is calculate empirical formula. Now what they want next is, if we look back, that is they want us to calculate empirical formula as well as the molecular formula. And one thing they have more given, they have also given us what? They have given us the molar mass. Now using this molar mass, we will calculate the molecular formula as well. Now what to do? For that, follow step number 4. That is empirical formula to molecular formula. Now for this, what we have to do? We have to first of all calculate empirical mass. Now I have to calculate empirical mass, which will be, there are 2 hydrogens, that is 2, plus there is 1 chlorine, a carbon, that is 12, and 1 chlorine, that is 35.5. Now what is the total mass which is coming? Tell me. This is 35.5, that is 4749. So this is coming out as 49.5 grams. Yes, so empirical mass, it is coming out as 49.5 grams. Okay. Now then what I will do? I will find a number, that is n. Now what is n? N is simply a number which is denoted by what? It is the ratio of molar mass. It is the ratio of what? That is, here they have given us molar mass divided by empirical mass. So what is n? It is molar mass divided by empirical mass. Now this I have to calculate here. So what is the molar mass? Molar mass is 99, whereas empirical mass was 49.5. So what is n coming out as? N is 2. Now this is next in the 4th step part. What I will do? I will find this n. Now is this thing clear at this moment? Finally, when I have to write the molecular formula, no, to write molecular formula, it simply is, what is my molecular formula? It is simply n times empirical formula. So n times empirical formula is my molecular formula. So what is n? N is 2 times empirical formula is H2CCl. So what is the molecular formula? It is coming out as H4C2Cl2. Now this is our answer. Now is this thing clear? Are you guys clear with the steps? If you guys have to see again, look at them. That is, first of all, calculate what? Convert mass percentages to mole percentage. Then find the ratio of those moles. Then from here, calculate the simplest whole number ratio. Yes. And then calculate the empirical mass formula. From here, calculate empirical mass. From there, calculate n. And from there, find the molecular formula. Now, are the steps clear to you guys? Any problem in any step? Tell me. If it is clear, then we will follow when we will solve one more question for this specific. Yes, exactly. It is very, very easy. You guys just have to follow these steps. Okay? Surely. So, let's try one question. See how many of us can get the correct answer for this. Okay. So, this is the question. Again, follow the same steps and try to get the answer. Yes. First, tell me in the comment section what is the empirical formula and then the molecular formula. Try this. Follow the same 4 steps and get the answer. Don't miss any step. It is very simple calculations. Okay. So, try your best. Give me the correct answer. So, are you guys trying this question or not? What is the answer? Again, we have to follow the simple step, that is, assume 100 grams of the compound. So, what is my compound? I have a compound having 100 grams. Yes, in the 100 grams of compound, I have hydrogen as 6.67 grams. My carbon is 40 grams. And what is my oxygen? Oxygen is 53.33 grams. Yes. Now this is okay. Empirical formula Anushri has given. So let's see if that is correct or not. Now what is the first step? First step is calculate the moles. That is moles of hydrogen. They are coming out as 6.67. Exactly. Divided by 1. That is same. 6.67. Then moles of carbon we are having 40 divided by 12. So this value will be close to 3.3. And then moles of oxygen. It is 53.33 divided by 16. Again this is close to 3.3. Yes, this is step number 1. Now what is step number 2? Step number 2 is find the ratio. So hydrogen is to carbon is to oxygen. This value is coming out as 6.67 is to 3.3 is to 3.3. Yes, in step number 3 what we will do? In step 3 we will simply find the simplest whole number ratio. Yes, Anushri has even given us the molecular formula. Anushri, so what do you think is the compound name? Can you guess the name of the compound? So it is find the ratio, that is divide this by 3.3. So this value is coming out as H is to C is to O. This is coming out as 2 is to 1 is to 1. So what is my empirical formula? That is, in case I have to calculate empirical formula, it is coming out as H2 C and O. So this is my empirical formula. Okay, that is CH2O. Exactly, Anushri. So what is my empirical formula? Empirical formula, I need some space here. Wait just a second. Okay, so if I have to calculate empirical formula, so empirical formula, empirical mass first of all. So what is my empirical mass? It is coming out as carbon is, what is the mass of hydrogen? 2 plus carbon 12 plus 16. Oxygen, yes. So this mass is coming out as 30. So next I have to calculate N. N is molar mass divided by empirical mass. This is coming out as 180 by 60. 180 by 30, that is 6. And in the last step I have to calculate molecular formula. So what is my molecular formula? It simply is N times empirical formula. Now this is coming out as 6 times. Then we have what? C1H2 and O. CH2O. So this is coming out as C6H12O6. And if you guys are familiar, this is the structure of what? This is the structure of glucose. Okay. So exactly this can, again, this can show what? This can show me glucose. It can be different. But at this moment, the molecular formula, it is representing glucose. Okay. Exactly. Sure. So let's proceed. Then there is the last concept of percentage purity. So let's see. The next topic is percentage purity of a substance. So sometimes what can happen, for example, let's say you went to a shop. Let's say I went to a shop, and in the shop I wanted, this is my shop. Now when I went to the shop, I wanted, let's say 100 grams calcium carbonate. Yes, so I wanted 100 grams calcium carbonate from the shop. Now what happened? The shop owner, he simply gave me, he thought I am not, very smart. So he simply gave me, let's say 90 grams of calcium carbonate. So what he did, he gave me 90 grams calcium carbonate plus he mixed it with some, let's say, impurities of similar type. Now what is the mass of impurities? It is 10 grams. So he simply gave me 100 grams of a sample, yes. So he gave me what? He gave me 100 grams sample, out of which there we had 90 grams calcium carbonate and 10 grams impurities. Now he thought I am fool. Yes, but I am not a fool. I simply calculated what is the percentage purity. That is, behind every 100 grams of a sample, how much exact pure compound, pure calcium carbonate do I have? So when I am calculating behind every 100 gram sample, what is the amount of calcium carbonate that I am having? I am simply calculating the percentage purity. Now what is meant by percentage purity? Again, if I have to calculate percentage purity, what is the formula? It is mass of pure sample, mass of pure element or compound, divided by mass of sample times 100%. Now this is what? This is my percentage purity. Now whenever you are calculating percentage purity, you simply look at what? You simply look at the total mass of sample. So in our case, what is the percentage purity? What is the mass of pure compound I am? I am having 90 grams. So here I can write 90 divided by sample size was 100 times 100%. Now this value is coming out as 90%. So my sample is 90% pure. But there is one thing which is important, and that is when we are talking about impurities, we always assume these impurities are inert. So whenever we are talking about the impurities, we are assuming that impurities are inert. They are not affecting anything. They are just there to look at the show, nothing else. So in this case of impurities, impurities are inert, no reaction with impurities. Who will react? My compound will react. So this is important. That is, impurities are there just for looking at the show. Okay. So look at this question. Then let's try a question on this, and with this we will finish our mole concept completely. That is the volume in liters of CO2 liberated when at STP when 100 grams of pure limestone is heated. Now the question is, this is a reaction, that is CaCO3. This is known as limestone. This is heated, and what this gives? It gives me lime plus CO2 gaseous. So this is the reaction which is given. Now they are saying you are provided with a sample that is of 10 grams. So what is my sample? Sample of calcium carbonate I have been provided, and what is the sample size? That is of 10 grams. So they have given me 10 grams of sample, but it is 90% pure. That is, the percentage purity is 90. Hence, out of 10, if I am multiplying it by 90, so mass of pure calcium carbonate. So mass of pure calcium carbonate, it is coming out as 10 times 90%. Now this value is coming out as 9 grams. So in this very example, we are having 9 grams of pure calcium carbonate. So the question simply says, for every 9 grams of calcium carbonate, what is the volume of CO2 liberated at STP? This is what they are asking. Yes? Tell me. Okay? Is this thing clear? Ashwin, this question, these are asked in your NCERT as well, empirical as well as molecular masses. These questions are asked in your NCERT and NEET as well. You can use this for KVPY or even though, okay? So don't worry, it will cover all the level of examination that you are preparing for. Now this is 9 grams of calcium carbonate. Now look at the equation. What does the equation tell me? Equation simply tells me for every 1 mole of calcium carbonate, 1 mole of CO2 is produced. That is 1 mole calcium carbonate, it will produce 1 mole CO2. Yes, and what is the mass of 1 mole calcium carbonate? It is 100 grams. So 100 grams calcium carbonate, it is producing 1 mole of CO2 means at STP that is 22.4 liters CO2. Now this is what I know from the equation, but what they want what is the amount of CO2 produced at STP when there is 9 grams calcium carbonate. So for 9 grams calcium carbonate, what is the amount of CO2? Let's say it is X liters. So from here, using unitary method, we can calculate X, that is 22.4 times 9 divided by 100, and this is my final answer. Exactly. Ashwin, I am starting organic, don't worry, I am there for you. I will take organic as well, okay? So is this thing clear? Any problem with this? Okay, so this is all about mole concept. Again, mole concept is not a simple chapter. There are 2 parts. we have completed the first part. There is another part that we will cover in redox. So in the redox section, we will learn about normality, we will learn about ppm, we will learn about equivalent masses and all. So it will be done when we are thorough with redox. At this moment, mole is finished. Okay. So with this, thank you for joining and all the very best. Do practice these questions, do revise and take care of your health. Thank you.